These are explanations on the answers and the functional group extra naming / drawing practice. You're also identifying in this homework. I'm going to start by showing you the identifications for 1 through 5 and walk you through drawing them. Fast forward through what you already know. AL ending is what allows me to identify this as an aldehyde. My chloro in this name allows me to identify that as a halide. OL allows me to identify that as an alcohol. O8 is an ester, and amides are amides. When it comes to drawing, butanal, but means 4 carbons. So my aldehyde, the C with the double bonded O has to come on the end. Remember, that does really follow with an H right there. So that's my aldehyde functional group, my double bond, just one of them being on an end carbon. And since this is but, I have 4 carbons in the molecule. For my halide, they're telling me I need 2 chlorines. Di means 2 chlorines. And those chlorines are going to go on carbon 3. I have a 5-carbon chain since that's a pentane base to it. 2-hexanol. My OL ending tells me that I need an alcohol group. That alcohol group is on carbon 2. Hex means 6. I started by drawing 6 carbons. On my second carbon in, carbon 2, I drew this OH group. You can put this up or down, it doesn't matter. You could also have numbered in the other direction, as long as it's the second carbon in. Propylethanoate esters are very difficult. You need to really look at that example that's given to you. The propyl part right here, which means 3, this is actually talking about the branch coming off the single bonded oxygen. The ethanoate part, this 2-carbon base right here, that has to actually contain the functional group in it. So the propyl is my 3-carbon chain over here. And I know this kind of appears a little bit backwards. My functional group is right here, and my functional group must have 2 C's in it because of this ethanoate right here. So this is referring to that F base. Esters are definitely the hardest to name and draw. For my pentanamine, pent means 5. Amide means my end carbon is going to have a double bond and an NH2. 1, 2, 3, 4, 5. I just plop that right on the end. 2,2-pentane diol. Diols will not be tested or quizzed, but they are nice to have an understanding of. My OL ending means that's an alcohol. Diol is just referring to the fact that there are 2 of them. That's the difference on that one. Amine ending is an amine. Hexane. Actually, I'm going to go back for a moment. Sorry. I would like to do condensed structures for these. So my condensed structure here, CH3, CH2, CH2, CHO. So my aldehyde, I'm condensing that ending down to CHO. You won't really need to worry about condensing halides too much. This would be CH3, CH2, CCl2, CH2, CH3. Apologize for running out of room there. I'll go over hexanol. This OH group will be shown coming off of the molecule. For my propyl ethanoate, this would be CH3, CH2, COO, CH2, CH2, CH3. Remember, again, you have this cooch, I guess you could say, in the middle of your molecule. You don't really need to worry about condensing your amides. Back to this page, sorry about that. Bromo and chloro in this are what tell me it's a halide. My ether ending tells me this is an ether. My own ending tells me that this is a ketone. So again, with my diol, pentane means 5. I put 5 carbons in a row. On carbon number 2, I put my diol, my 2 alcohol groups. Again, you'll only be asked to do monohydroxy on the quiz. 2-butanamine, but means 4. I actually have a mistake here. That is my bad. Sorry. We're going to stick that NH2 group right there. Again, you could, if you number in the other direction, sticking that on that carbon would be fine. It just needs to be on carbon number 2. But means 4, so I have 4 carbons in a row. 1, 2, 3, 4. You won't really need need to worry about condensing that either. The NH2 would be shown coming off of the chain. For my 2-bromo, so 1,2-bromo, 3-chloro, 4, 5, 6 for hexane. Methylpropyl ether, my methyl is referring to a 1-carbon branch. This is my methyl branch right here. My propyl is referring to a 3-carbon branch, which is right here. Does not matter which way you do these. If you did 3 on the left and 1 on the right, it would be fine. This is one that you want to recognize condensed. This would be CH3O, and then CH2, CH2, CH3. So we have that single bonded O in there. It's not directly on a C. I want to contrast this with a ketone in just a moment. I know that this is going to be a ketone because of that own ending. And in a ketone, my number tells me where that double bonded oxygen is going. Hex means 6. 1, 2, 3, 4, 5, 6. So since this is 3-hexanone, that's where my double bonded O is going. When you're condensing this, this is going to condense down to CH3, CH2. My functional group right here is just becoming CO, CH2, CH2, CH3. Notice each of these have a functional group with one O. In the ketone, that O is actually written right next to that C that it's double bonded to. And finally, we have propanoic acid. Oic acid means acid. One means this is a ketone. So propanoic acid has to have 3 carbons in it with my functional group on the end. You do need to be able to recognize this condensed. CH3, CH2, COOH. Propanone. This is actually a ketone. It has to be on the middle C, so you actually don't need a number with this because it would always be 2-pentanone. If you drew a 3-carbon molecule and put your double bonded O on the end, this would be an aldehyde now. So if you were to name this compound and call it 2-propanone, that would totally be fine, but you don't actually need that. And this would condense to CH3CO, CH3. So we see that double bonded O condensed into the molecule. For identifying functional groups from a structure, 2 O's, 1 double bonded, 1 kind of in an OH conformation. That's my organic acid. I have F and I here. Those are from group 17. Those are halides. This molecule is condensed down. There's a Cl hiding. That's also a halide. This is an alcohol because I have that single bonded OH group. So my 4-carbon alcohol for number 13 becomes butanoic acid. When I'm naming my halide, 1, 2, 3, 4, 5, 6, 7. Not a huge deal which order you put these in, but you need the 2 with the fluorine, 3 with the iodine, and then heptane for my 7 carbons. 2-chloropentane. You might want to draw this out to see that Cl is bonded to that chlorine. For my alcohol, I have 1, 2, 3, 4. My OL ending, so I'm going to have, instead of butane, butanol, and my OH group is attached to carbon 2. For my aldehyde, this is a condensed formula. This is something you need to be able to recognize. So the CHO right here. To show that drawn out, just for your eyes, we got CH3, CH2, CH2, C, double bonded O, and H. That's what that CHO actually means. So you do need to be familiar with that abbreviation. That is an aldehyde with 1, 2, 3, 4 total carbons. So butanal. So butane becomes butanal. Again, condensed Cu group. Remember what that actually looks like? Would be this. So that's my organic acid. I have 3 carbons here. Prop for 3. Propanoic acid. The ether can be a little bit tricky when shown in its condensed form. So I'm going to draw number 19 out. I have CH3, CH2, then I have this O that's actually single bonded to that C, and then I go CH2, CH3. So by filling in the hydrogens, it really helps clue you into the fact that, these C's right here are each saturated with hydrogens. So that means that guy's got to be just a single bond in that chain. So we have our one O here in the middle. To contrast that again, with in a ketone, you tend to see like a co in the middle because that C is double bonded to that O, so it doesn't have any other H's on it. So this is an ether. On this side of the ether, I have an ethyl group. And on this side of the ether, I have an ethyl group, so I'm going to call this diethyl ether. Number 20, I have a double bonded O, no other O's in the whole molecule. So this narrows this down to either a ketone or an aldehyde. Because this is on the end carbon, there's no other carbons here that's an H, carbon chain stops. This is an aldehyde. 1, 2, 3, 4, 5, 6. Actually, technically, the correct way to number this would be putting the functional group on the end. But either way I go, I get 6 carbons in a row. So instead of hexane, this becomes hexanal. And last but not least, I apologize, that is an amide. My amide for my last one has a double bonded O and an NH2 group. You don't need to worry about numbers with these. This will come on the end. I have a total of 5 carbons here, so therefore this is pentanamide. I drew out number 22 for you. What I want you to see there, we have the CH3 for our first carbon, CH2. This CO right here, because there's no other H's on that, that's indicating that double bonded O. And then we go on to continue our CH2, CH3. I have one double bonded O in the molecule. Therefore, this is a ketone. If you're having trouble getting to this structure, I would start by looking at the fact that I have one O. You can at least narrow it down to, whether or not you have an ether or a ketone or an aldehyde, and then you've narrowed it down and can use table R to help you draw your structure. So for my ketone here, I do need to put a number with this. I have a total of 5 carbons. 1, 2, 3, 4, 5. If I number in the other direction, this is always coming up on carbon 3. So this is going to be 3-pentanone. Next one's also a ketone. This is drawn out. I have that double bonded O on a non-end carbon. And that's going to be carbon 2 if I number in this direction. So it's going to be 2-hexanone. I drew out this ester for you also because we see that COOH kind of in the middle of the molecule. I don't like to call it a COO group and get confused. I have my CH3, my C with my double bonded O, my single bonded O, ending in CH3. This C that's single bonded off of that O is what makes the methyl part of this name. The 2-carbon part with the double bonded O is what makes the ethanoate part of this name. I know this is a little bit backwards. Could you draw this the other way? You could put a methyl group, then a single bonded O, then a carbon with a double bonded O, and add your last carbon there. The problem with this is it looks completely different from table R, so it's not wrong, but it could cause you to get this backwards. So I just recommend understanding, hey, it's a little bit weird, it's a tricky example, but you've got table R to help you with this. Your quiz objectives. Number 1, given a condensed formula, identify compounds by class from table R. Make sure you have these written on your reference table. For example, you see this ending right here, it's an aldehyde versus seeing this is going to be an alcohol, okay? So just be sure you understand, the examples between those. COO groups, knowing what the ester looks like when it's condensed, the ether, the ketone. Number 2, given a name of a compound, draw a complete structural formula. So if you're given butanoic acid, be able to draw your formula showing all your appropriate bonds. You don't need to write condensed formulas. Given a structure, write the correct IUPAC name. IUPAC naming is all we do. So name it the way we did it based on reference table R. So in this example, I would say, hey, this is an ether. I got that single bonded O in the middle. I got 2 carbons over here. I got 3 over here. Ethyl propyl ether. There may be a small amount of condensed formula involved with this, but most of them will be drawn out a little bit more clearly. Only monohydroxy alcohols, so no triols or diols, will be on this quiz. So study these examples. Remember, be very dependent on table R. That's really the most important thing you can do to do well in this quiz.